Welcome to this video on the topic of fractions. In this video, we're going to have a look at how we can multiply fractions together. Fractional multiplication can be done in two steps. The first step for fractional multiplication is we firstly need to multiply the numerators together. The second step is we multiply the denominators together. Sometimes when we're doing this, we add a few more steps, such as simplification as we're going. However, let's start off by keeping it simple. We're going to go example 1, simplify. First example is going to be simplify 5 over 4 times 7 over 3. This will be simplified by, firstly, multiplying the numerators together, and after that, we'll multiply the denominators together. Starting off, I draw my equal sign. I then draw an extended vinculum. I'm going to get my numerators 5 and 7, and they're going to be multiplied together. I now get my denominators 4 and 3, and they're going to be multiplied together as well. I go to a new line by drawing the equal sign immediately underneath the first one. I then draw my vinculum in. 5 times 7 gives me 35. 4 times 3 gives me 12. So, the multiplication of 4 over 5 and 7 over 3 is equal to 35 over 12. The method being we multiply the numerators together, we multiply the denominators together. Let's have a go at another example. B. We're going to go negative 3 over 2 times 5. Now the process we're going to employ is exactly the same. However, we need to make sure that all our numbers here are firstly represented as fractions. Our first one is good, although it is negative. Our second one needs some work. It's a 5. This is a whole number, we want it as a fraction. The way in which we can write this as a fraction is we just pretend. So, let's get into it. We'll write our equal sign, and we'll put that negative at the front, and then our first fraction's 3 over 2. Next, we're going to write 5 as a fraction. I start off by writing 5, and then I pretend it's a fraction by putting it over 1. Okay, I'm now ready for the multiplication. I have a negative at the front here. Whenever I have a negative, I just move it at the very front. I now draw an extended vinculum. My numerators are 3 and 5. They're multiplied together. My denominators are 2 and 1. They're multiplied together. I now do the multiplication. Negative stays at the front. I haven't done anything with it. I draw my vinculum. 3 5s are 15. 2 1s are 2. Therefore, the simplification of negative 3 over 2 times 5 is negative 15 over 2. So this is the first degree of complexity. We always multiply the numerators together, then multiply the denominators. Now let's have a look at the next level of complexity. Example 2, we want to simplify yet again. We have two fractions yet again. One happens to be negative, but we know how to deal with those. What we're going to do with this is we're going to use a showcase of how we can simplify before we start the multiplication. This will in turn make sure that the multiplying is less difficult. So starting off, I'm going to draw an equal sign, and I'm going to pretend everything is exactly like it's before. I see that there's a negative in front of the second fraction, so what I'm going to do is I'm just going to move it all the way out to the front. I now draw an extended vinculum. My numerators are 10 and 7. They're going to be multiplied together. My denominators are 7 and 3. They're going to be multiplied together. Now at this point I put the brakes on and I stop. I have 10 times 7 over 7 times 3. If I think back to the previous lesson about simplification, I remember that if I have common numbers in numerator and denominator, I am allowed to cancel them out. I have 2 7s. One is here, another is here. Because they're matched up across numerator and denominator, I am allowed to kill. The 10 and the 3 do not match, so I will keep. Moving to my next line, my negative is unchanged. I draw a vinculum. I have left over a 10 and a 3. So I was able to multiply these two numbers over here without actually having to do any multiplication because the 7's cancel. So 10 over 7 times negative 7 over 3 is the same as saying negative 10 over 3. Let's go to example B. Example B, we have negative 3 over 2 times negative 5 times 2 over 3. We have a question of similar complexity. Where this cosmetically looks different is that we have two negative signs. Secondly, in the second fraction, we have a times going on already. The way in which we're going to deal with this is using the exact same method we used up here. So let's give it a go. I'll start off by drawing the equal sign. Next, I'm going to move both of the negatives, this one and this one, out to the very left. So I go negative, negative. I'm now drawing a vinculum. My numerators are 3, 5, and 2, and they are all being multiplied together. My denominators are 2 and 3, and they are all being multiplied together. It's at this point, I think, can I play keep or kill? I see I have a 3 here and a 3 here. Because they're matched up, I'm allowed to cancel both of them out so they kill. Next, I have a 2 and a 2. They match up, so I kill. I go to the new line, I say equals. Now I look above here and I have two negative signs. Because these two negative signs are together, what's going to happen is they're going to turn into a plus. So I'm going to get positive, vinculum, 5, and then I find I've got nothing downstairs. Because I've run out of factors downstairs, I cancelled everything out, I just put a 1. So the answer to this is going to be 5, because anything over 1 is just equal to whatever's upstairs in the numerator. So 5 over 1 is 1, or 5. The plus doesn't need to be there, I've just put it there so you can see the two negatives make a positive. So in summary, negative 3 over 2 times negative 5 over 2 all over 3 is the same as writing 5. We found this out by simply following the process that we did above. Move the negatives out all the way to the left, then gather all your numerators, multiply them together, gather all your denominators, multiply them together. If along the way you have double up between numerator and denominator, you are allowed to cancel them out, which simplifies the multiplication. Alright, let's move on to example C. Or not, let's move on to example 3. Example 3, we have simplify. Negative 5 over 6 times 3 over 10. The way in which we're going to simplify this is using the exact same method we employed before with one extra step, simplification further. To begin, I draw my equal sign and I'm going to move the negative all the way out to the left. I then draw an extended vinculum. I'm going to have my numerators are 5 and 3, so it's going to be 5 times 3. My denominators are 6 and 10, so it's going to be 6 times 10. Notice that I don't have any double ups between numerator and denominator, so there's nothing to cancel, or at least nothing obvious. I go to the next line and I do the actual multiplication. Negative goes out front, vinculum. 5 3s are 15, 6 10s are 60. So at first glance, the answer is going to be negative 15 over 60. However, if I remember back to the previous lesson, I can simplify these fractions. To simplify, I draw my factor trees. We're going to go 15. Can I divide 15 by 2? No, but I can divide it by 3. If I divide it by 3, I'm going to get 3 and 5. For 60, I'm going to say, can I divide it by 2? Yes. This is going to be 2 and 30. I turn my attention to the 30. Can I divide 30 by 2? Yes, I can. I'm going to get 2 and 15. And then the 15, I already know that's going to be 3 and 5. As a consequence, I can see the factors for this are 2 times 2 times 3 times 5 and 3 times 5 for the 15. I'm now going to use these factors to write the fraction negative 15 over 60 in its simplest term. This will be done by dropping the equal sign even further. I draw my negative and then I draw my vinculum. It's going to be extended because I've got quite a few factors here. Upstairs it's going to be 3 times 5. Downstairs it's going to be 2 times 2 times 3 times 5. I now cancel out what's common across the two. I have 3 and 3, 5 and 5. Moving down, what I can see is that nothing is remaining upstairs, so I put a 1 and I've got 2 by 2 downstairs. So the answer to this is going to be negative 1 over 4, or negative a quarter. Therefore, it can be seen that negative 5 over 6 times 3 over 10 is the same as saying negative 1 over 4. I do this by firstly using the same method I used in the previous examples. I multiply numerators and denominators together. I get my result. I then choose to simplify. I can use a factor tree to get this done. I then write everything as the product of factors and I cancel common factors across numerator and denominator. I then multiply what's left over together and thus I come to my answer. This is a long process. If you understand your factors and you can do it automatically in your head, then you can skip all of this step together and you can start factorizing up here. However, for now, you're going to use the factor trees until you're proficient enough to see all factors. Let's go on to example B. We have negative 3 over 7 times negative 14 over 3. We simplify this by using the exact same method we used above. We start off and we get our two negatives and we write them out front together. We then draw an extended vinculum. We're going to say 3 by 14 because those are our numerators, and 7 by 3 because they're our denominators. Next, we're going to simplify those two negatives and they're going to turn into a positive. So we end up getting 3 by 14, 7 by 3. We now notice that we have a double up of 3 in numerator and denominator. We can cancel these out. So we say goodbye to the 3's. We kill them. Next, we go to a new line. We have 14 over 7. We can do better than this. We can factorize this. So we start off and we say, what are the factors of 14? The factors are 2 and 7. For 7, we just have a factor of 7. Moving along, we go back to our fraction and we write our fraction as the product of our factors. I have 14 upstairs, or I can write 2 by 7. Downstairs we have 7. We cancel the double up, so the 7's are killed. Hence, we have 2 over 1, which is the same as saying 2. So in summary, the multiplication of negative 3 over 7 times negative 14 over 3 is the same as saying 2. So this concludes all of the types of multiplications that you could see when you're multiplying fractions together. It is important to remember when multiplying fractions we multiply numerators and then we multiply denominators. Along the way, we choose to simplify by cancelling out common factors. This can be done by cancelling out the obvious, as well as drawing the factor trees, writing it as the product of factors, and then cancelling out the factors. When you become proficient, you can cancel from here and go from here down to there. However, before this, you must first practice factor trees.